Imagine standing in the middle of the Sahara Desert. In every direction, there is nothing but shifting orange dunes and a sun so intense it feels like a physical weight on your shoulders. It is one of the most silent and isolated places on the planet. But right now, miles beneath the sand you are standing on, a massive underground facility is humming with the power of a small city. Scientists have built a cavern so deep and so shielded that it is the quietest place in the universe for subatomic particles. In early 2025, an experiment inside this facility detected something that was supposed to be impossible according to every physics textbook written in the last 50 years. They found a signal that suggests our understanding of the fundamental forces of nature is incomplete. This discovery didn't just break a rule. It revealed an entirely new layer of reality. Today we are going deep beneath the desert to explore the experiment that is rewriting the laws of physics and why the Sahara was the only place on Earth where this mystery could be solved. To understand why this is such a massive deal, we have to look at the current state of science. For decades, physicists have relied on something called the Standard Model. This is the ultimate rulebook for how the universe works. It explains how particles like electrons and quarks interact to build everything we see, from the screen you are looking at to the stars in the distant sky. For a long time, the Standard Model was perfect. Every experiment we ran confirmed it, but there was always a nagging problem. The Standard Model couldn't explain gravity, and it couldn't explain dark matter, the invisible stuff that makes up most of the universe. Scientists knew there had to be something else, a new physics hiding just out of reach. The problem was that the Earth's surface is too noisy to find it. Our planet is constantly bombarded by cosmic rays from space. These are high-energy particles that fly through your body every second. They are harmless to us. But for a delicate physics experiment, they are like trying to listen to a whisper in the middle of a heavy metal concert. To hear the whisper of new physics, you need a giant shield. You need miles of solid rock to block out the cosmic noise. This is why the Sahara was chosen. In a remote region of North Africa, the geological conditions provided the perfect combination of depth, stability, and total isolation from human electromagnetic interference. The facility is called the Deep Desert Neutrino Observatory. It consists of a massive tank filled with ultra-pure liquid scintillator, surrounded by thousands of the world's most sensitive light detectors. The goal was to study neutrinos, which are often called our ghost particles. Neutrinos are so small and so weakly interacting that they can pass through a light year of solid lead without hitting a single atom. Trillions of them are passing through your thumb right now. Because they are so hard to catch, they are the perfect messengers from the far reaches of the universe. If there is a new force of nature out there, the neutrinos are the best candidates to show it to us. In January 2025, the team at the observatory noticed a bleach in their data. According to the Standard Model, neutrinos come in 3 flavors, and they oscillate between them as they travel. The math for this is very precise. But the Sahara experiment was seeing a 4th type of oscillation that shouldn't exist. It was as if a ghost particle was turning into something even more ghostly. After months of checking the equipment for errors, the researchers had to face a shocking reality. They had confirmed the existence of the sterile neutrino. This is a particle that doesn't interact with any of the known forces of nature except gravity. It is a particle from the dark sector of physics. This discovery changes everything. If sterile neutrinos exist, it means the Standard Model is just a small part of a much larger, more complex map of the universe. It provides the first real link between the world we see and the world of dark matter. Scientists believe that sterile neutrinos could be the building blocks of the dark matter that holds galaxies together. By finding this signal under the Sahara, we have effectively found the missing link of the cosmos. It's like discovering a new room in your house that you've lived in for 40 years, except that room turns out to be 10 times larger than the rest of the house. But the experiment didn't stop there. By tracking these sterile neutrinos, the team noticed another anomaly. The particles were displaying a behavior called time reversal asymmetry at a level that was much higher than predicted. In simple terms, this suggests that the laws of physics might not work the same way moving forward in time as they do moving backward. We've always assumed that on a subatomic level, time is symmetrical. But the Sahara data suggests there is a fundamental arrow of time baked into the very fabric of particles. This could explain one of the biggest mysteries in science: why the universe is made of matter and not antimatter. If time has a preferred direction on a quantum level, it explains why matter won the big battle at the beginning of time, allowing us to exist today. The conditions inside the Sahara lab are a feat of engineering on their own. To keep the detectors from being triggered by heat, the entire tank is kept at a temperature just a fraction above absolute zero. The water used in the cooling systems is the purest water ever created by humans, stripped of every single radioactive isotope. Any tiny speck of dust could ruin years of data. The scientists living and working in this underground city have to wear specialized suits and pass through multiple airlocks. They are effectively living like astronauts, but instead of looking up at the stars, they are looking down into the very heart of matter. The 2025 discovery has sent the global scientific community into a frenzy. Laboratories in Europe, America, and China are now racing to upgrade their own facilities to verify the results. But the Sahara team has a major advantage. Their location allows them to point their detectors toward the center of the Earth to study geoneutrinos, particles produced by the radioactive decay inside our own planet. By combining the data from distant stars with the data from Earth's core, they have created a stereoscopic view of physics that no one else can match. They aren't just seeing new particles. They are seeing how those particles interact with the gravitational field of the Earth in real time. Some theoretical physicists are already calling this the Sahara Revolution. They believe that the sterile neutrino is just the tip of the iceberg. If there is a dark sector of particles, there might be for dark photons and dark forces that we have never dreamed of. We might be on the verge of discovering a fifth force of nature. For a long time, we've known about gravity, electromagnetism, and the strong and weak nuclear forces. But the way the sterile neutrinos behaved in the 2025 experiment suggests there is a fifth influence acting on them, a force that only talks to the dark sector. Think about what this means for the future of technology. Every time we understand a new force of nature, we transform the world. When we understood electromagnetism, we got light bulbs, computers, and the internet. When we understood nuclear forces, we got nuclear power and medical imaging. If we can learn how to manipulate the dark sector and this fifth force, we are talking about technologies that look like magic today. We could potentially develop ways to communicate through solid planets, or even manipulate gravity itself. The Sahara experiment is the first step toward a future where we aren't just passengers in the universe, but active participants in its most fundamental layers. The isolation of the Sahara also offered another unexpected benefit. Because the facility is so far from any urban centers, it is uniquely sensitive to quantum gravity effects. These are tiny fluctuations in space-time that are usually drowned out by the vibrations of human activity, like trucks driving on highways or the hum of the electric grid. Underground, in the silence of the desert crust, the 2025 experiment detected ripples in the quantum field that match the predictions of string theory. For the first time, we have experimental evidence that space-time might not be a smooth fabric, but rather a pixelated mesh made of tiny vibrating loops. The data from the Sahara is currently being processed by the world's most powerful supercomputers. It is so vast and so complex that it will take years to fully map out every detail. But even the preliminary results have already debunked several long-standing theories. For example, some models of the Big Bang predicted that sterile neutrinos would be much heavier. The fact that they are relatively light suggests that the early universe was much cooler and more stable than we previously thought. It's forcing cosmologists to go back to the drawing board and rethink the first few seconds of existence. One of the most fascinating aspects of the project is the international collaboration. Despite various global tensions, the Sahara facility has brought together thousands of scientists from dozens of countries. There is a sense that the mystery they are solving is too big for any one nation. Inside the control room, you'll find experts from different cultures all staring at the same glowing screens, waiting for the next chirp from the dark sector. It is a reminder that when it comes to the fundamental laws of the universe, we are all on the same team. The local impact of the experiment is also notable. To power the facility, one of the world's largest solar arrays was built on the surface above the dunes. The clean energy generated by the Sahara sun is sent down through high-voltage cables to run the cryogenics and the computers. It's a beautiful irony. The energy from the most visible object in our sky, the sun, is being used to find the most invisible particles in the universe. The project has also led to a KPEC in a region that was previously considered uninhabitable. New roads, satellite links, and water desalination plants have been built to support the site, bringing modernization to a remote part of the world. But why 2025? Why did it take until now to find this? The answer lies in the sensors. The light detectors used in the Sahara experiment, called silicon photomultipliers, were only perfected in the last few years. They are so sensitive that they can detect a single photon of light reflected off a mirror a mile away. When a neutrino hits an atom in the liquid tank, it produces a tiny flash of light. Previous experiments weren't sensitive enough to distinguish these sterile flashes from the normal ones. It took a quantum leap in sensor technology to finally peer through the veil. As the news of the Sahara discovery spreads, it's sparking a renewed interest in science among the general public. People are starting to realize that the era of great discovery isn't over. We often think that everything important was found by Newton or Einstein, but the 2025 experiment proves that we are still in the middle of the story. There are still deep mysteries waiting to be solved, and they are often hiding in the most extreme and unexpected places on our planet. The scientists at the observatory are already planning the next phase of the experiment. They want to expand the tank and add even more detectors to see if they can catch a Becker matter event directly. If the sterile neutrino is the messenger, they want to find the source. They are also looking into using the facility as a quantum seismograph to predict earthquakes by detecting tiny changes in the Earth's gravitational field before the tectonic plates even move. The possibilities are endless when you have a direct line to the fundamental fabric of reality. What does this mean for you, the average person? On a daily basis, maybe not much. Your coffee will still be hot and your car will still run on tires. But on a deeper level, it changes the context of our existence. We now know that we are part of a universe that is much richer and more mysterious than we ever imagined. We aren't just living in a world of matter. We are living in a world that is deeply intertwined with a dark, invisible sector that we are only just beginning to understand. It's a bit like a sailor who has spent his whole life on the surface of the ocean suddenly discovering that there is a vast, thriving world miles beneath the waves. The Sahara discovery also reinforces the importance of frontier science. These are experiments that don't have an immediate commercial application but are done simply to expand the boundaries of human knowledge. Without this kind of curiosity, we would never have progressed beyond the Stone Age. The $10 billion spent on the Sahara Observatory might seem like a lot, but how do you put a price on finally understanding what the universe is made of? It is an investment in the intellectual capital of the human race. As we look toward the 2030s, the Sahara facility will likely become the most important physics lab in the world, rivaling CERN in Switzerland. It represents a shift from collider physics, where we smash things together, to observational physics, where we sit quietly and listen to what the universe is already trying to tell us. It's a more patient, subtle form of science, but as 2025 proved, it can be even more rewarding. The sheer scale of the 2025 finding is hard to overstate. In the world of physics, finding a new particle is the equivalent of a geographer finding a new continent. It changes the entire map. It forces every university to rewrite its curriculum and every researcher to rethink their life's work. The sterile neutrino is now a celebrity in the scientific world, and everyone wants a piece of the data. Reflecting on the discovery, the lead researcher of the project said that the most amazing part wasn't the particle itself, but the fact that we were able to build something sensitive enough to find it. It is a testament to human ingenuity. We took one of the most hostile environments on Earth, the Sahara, and turned it into a window into the divine mechanics of the cosmos. We used the depth of the Earth to see the breadth of the universe. The experiment also found that sterile neutrinos have a slight mass hierarchy, meaning they aren't all the same weight. This tiny detail is actually a huge clue. It suggests that there is a specialized mechanism for how particles get their mass, something that goes beyond the Higgs boson. If we can figure out that mechanism, we might be able to explain why some things in the universe are heavy and others are light. We might even find a way to lighten the mass of objects, which would revolutionize everything from space travel to construction. The 2025 event is a reminder that nature still has many secrets. We have only explored about 5% of the matter in the universe. The other 95%, dark matter and dark energy, is still a total mystery. The Sahara experiment is the first time we've truly breached the wall between the two. It's the first light in a very dark room. And what that light is showing us is a universe that is more beautiful, more complex, and more connected than we ever dared to hope. So, if you ever feel like the world is a small, predictable place, just think about the silence of the Sahara. Think about the giant tank of pure liquid miles beneath the dunes and the flash of light that changed everything we know about time, space, and matter. We are standing on the edge of a new frontier, and the view is spectacular. The laws of physics haven't changed, but our eyes have finally opened wide enough to see what was there all along. The Sahara facility is now a symbol of our species' relentless drive to understand the unknown. It shows that no matter how vast the desert or how deep the mystery, we will find a way to tunnel through. We are a species of explorers, and our greatest discoveries aren't just found in the stars or on distant planets, but in the quiet, shielded spaces where we can finally hear the whispers of reality. In the coming years, we will see a flurry of new papers, new theories, and undoubtedly some heated debates in the halls of science. Some will struggle to accept that the standard model needs such a massive overhaul. Others will dive headfirst into the new physics of the dark sector. But regardless of where individual scientists stand, the data from the Sahara remains. The flashes of light were real. The sterile neutrino is here, and the universe will never look the same again. As we move forward, we should hold on to that sense of wonder. The discovery in 2025 wasn't just for the physicists, it was for all of us. It is a reminder that we live in a universe of infinite possibilities, where the next great breakthrough might be hiding right beneath our feet, waiting for us to stop and listen. The Sahara Desert, once an ended waste, is now the birthplace of a new understanding of existence, and that is a discovery worth everything.